Swayam Prabha. Digital India. Educated India.
So, in yesterday's class we started looking at a basic inventory model and then slowly started to include the supply line aspect of it as shown in this stock flow diagram, and we found that this is causing unnecessary oscillations within the system because the supply line information was not used in the decision making of computing the desired order rate. That is where we kind of are exploring the model. So, today's class will further expand on that and include different aspects in the decision making and move towards the supply chain models. Now, first step is let us figure out how to account for the supply line in our decision making. So, what I mean by supply line is the one that shown in red. After things are ordered, after some supply delay, things are getting delivered. So, until then that quantity remains in transit. So, this is what physically is happening, we are captured that in the physical aspect of it, but in decision making you can find that none of that information is actually feeding into this decision making of the desired order rate. So, one way to account for it, okay, how do we consider supply line, that is the past and pending orders in transit when we make the new ordering decisions. Any thoughts how we can include the supply line decisions in a decision making, supply line information in our decision making. So, let us, the only other structure that we are familiar with is a simple negative feedback kind of system, where when we had only the inventory, we had a desired inventory and then adjusted the desired inventory to assure us a good quantity getting delivered or appropriate quantity getting delivered. Let us see whether we can mimic the same decision here. Before that, I hope all of you have the model, the previous one, you have all this model. If not, you can download the latest version. So, let us quickly see the dynamics before we proceed, so that we know what we are trying to correct. Yeah, so when we ran this model, we found that there is a dynamics in the order rate. Inventory fluctuates, and the quantity in transit is opening up the graphs for each. The order rate fluctuates and reaches then the desired new order quantity of 20 units. Initially it was 0 units, system was in dynamic equilibrium. The quantity in transit fluctuates and finally settles down around 40 units, and inventory after fluctuating comes to its desired value of 200 units. So, that's what we have. Now, let us go back to our model. Yeah. So, what we are going to do, we are going to adjust the in transit inventory in the similar manner as we have been adjusting the end inventory. So, let us define a desired in transit inventory and say that if the desired, based on desired inventory level, we will go ahead and adjust the in transit inventory to meet that desired value and see whether that can help in minimizing our dynamics. We saw that the inventory was able to reach its desired value, but the in transit inventory, it reached some value of 40, we do not know what it is. So, we let us try to figure out how we can do that. Once you do that, we will update the desired order rate to include this adjustment. Okay, so I would like you to update your model as shown in this diagram here. A few changes are after 10 minutes you will figure it out. For now we will assume some constant values. So let us see. So we have the quantity in transit, there is no change in this model here, but let us observe what I did here. You save as a current model to save inventory SL dot MDL, meaning supply line is now considered. The inventory gap is removed, it is now called adjustment for inventory. Right, they update the equations for that adjustment for inventory. Then we have the desired delivery delay, which is now the sum of adjustment for inventory and expected sales, and all the thing in red represents the decision making to include the information about quantity in transit. So, quantity in transit and desired in transit quantity, we are taking a difference of it in adjustment for in transit, then divided by time to adjust in transit, and order rate is now equal to the adjustment for in transit plus what is the desired delivery that we want. You got the structure updated in your model. Then let us look at the underlying equations. I am just starting with the equations for the stocks. So, the equations for inventory, quantity in transit, delivery rate is delay fixed. This was in the previous model, you do not need to update anything here. Sales rate is nothing but the integral of change in sales and change in sales, nothing but sales rate minus expected sales rate multiplied by fraction adjusted. This from the model that we just saw. So, all these are exactly same as the previous model. Okay. Now, let us look at adjustment in inventory. So, your adjustment in inventory will be the difference between your desired inventory minus your actual inventory divided by time to adjust inventory. So, your adjustment for in transit will also have the same form in transit, nothing but desired in transit minus in transit. I should say quantity in transit, but I think you will get it. Quantity in transit, this is the stock in transit quantity divided by time to adjust in transit. So, these are two variables that we are having. Now, we started to define new variables. One is called as a desired delivery. What will be desired delivery? Based on your stock flow diagram, desired delivery will be equal to plus expected sales rate plus adjustment for inventory. Okay. The desired order rate is desired delivery plus adjustment for in transit. And order rate is equal to desired order rate for now. So, you got this. The sales rate we assumed it's 0 initially, and then there is a step increase of 20 at time 5. That is what you assume for sales rate. The sales rate we took it as 0 plus step of 20 at time 5. The only equations you may need to fill up are these. For stocks, these are only new things that has come up. All others are, you will get it from the previous model itself. Only the last 5 you have to check. Desired inventory we had set it at 200, right? Desired inventory was 200 units. What do you want to keep the desired in transit as? Initially there is no orders, right? So, let us keep the desired in transit as 0. There is no orders right initially. So, let us keep the initial in transit as 0, or rather desired in transit as 0, as well as initial quantity of in transit also as 0, which is the default one anyway. I think you can just check it. So, just check if the initial value of in transit is 0. So, quantity in transit. Okay, now let us go back. Let me find out what it is. I think you can just say for time to adjust for inventory, what was the value we took? 3, then use 3. Time to adjust in transit also, let us keep it 3 days. Let me see what I have. Let us keep it 3 days. First time to adjust in transit as 3 days. Time to adjust inventory is also 3 days. Supply delay will be 2 days, if I am right. Now, this is important structure you have to understand. We now split the desired order into 2 parts. Earlier we called this desired delivery as the desired order rate, that is the sum of adjustment for inventory and the expected sales as equal to order rate, but now we are splitting it into desired delivery. Why is that? See here, if you recall the first model that you ever built, where we assumed supply is infinite and instantaneous, as soon as I want it I will get it, right. So, that is not actually the order rate, that actually what we wanted was things should be physically delivered to us, right. And just by using this adjustment for inventory and the expected sales, we can very well control the inventory to the desired levels that we actually want, correct. So, this sum of these terms here will help us manage the inventory stock here. Now, but in the final order what we want to do is account for this in transit quantities that is already in transit or quantity already in transit. So, that is why we want to give a distinction between them, which is why we call the desired delivery and desired order rate. So, let then simulate it. Earlier recall we had a dynamics in order rate. Let us see what we get here. Now, we do not get that big of a, we do not get any oscillation, we get an overshoot and then slow decay to the desired level that we want. There is an overshoot, but then there is a slow decay to level we want. There is no oscillations as we saw earlier. You can compare the order rate. I hope all of you know how to do multiple things in a graph. You just click order rate, click shift and then click sales rate. So, both the variables are selected, so that you can superimpose both of them like this. This is the actual sales rate and this is what the retailer has ended up ordering upstream. You can imagine, say order to some distributor, this is how much is the quantity that you are going to order. Let us compare inventory and desired inventory, select both. Okay, earlier model inventory model is in equilibrium, that is good, but what we see here, this desired inventory remains constant at 200, but your actual inventory, because of adding the supply, updating a model, suddenly my actual inventory is saturating at, not saturating, reaching steady state at 160 units, like 160 units. In a previous model, when we didn't account for it, we found inventory reaching 200 units, but right now it's only reaching 160 units. Let's see what happens, quantity in transit and desired quantity in transit. I hope you have put desired quantity in transit as 0. So we should get a value of 0. Quantity in transit -1. Oh no, okay. I didn't put the units, that's why the problem. This is kg. See, if you keep both these units same, okay. First, let me show the problem. First, let me show the problem and then I will come back. When we simulated, I wanted to do this. Observe the graph carefully. What it has done is desired quantity current and then there is open empty bracket here, quantity in transit current and there is a bracket kg. So, this quantity in transit uses units of kg and kg is plotted in x in the secondary axis, secondary y axis. This one is coming here on the left side. So, if you want both the graphs to show the same scale, then units should match. So, Vensim by default, if units are different, it will plot it in different axes as much as it can. You select 3 different variables, it will do something. The first is fix the units. This is kg. Now you do it. Now you again simulate, click quantity, click in transit. Now you will get a single nice graph. Okay. Some of these are just unplanned learning points. Yeah. So, in transit increases from 0. Initially, it is fine. We are able to meet the desired as well as the desired value same as in transit value, but after some time the actual value increases to 40 while the desired value remains at 0 because we set it at 0. Right. Okay. So, you just observe the results, system reach equilibrium, yes it reaches equilibrium. What are the equilibrium values of the stocks? We found that the in transit stock reaches 40 and the inventory reaches 160, both are different from their desired values.